Alright, today on page 45, we are going to perform some rotations. So let's turn to page 45. Our objective is to perform a rotation. So when we perform rotations, we can do it really using pen, paper, or a formula. And we're going to be using a formula here to do it. We'll talk more about using angles that aren't 90 degrees in class on Tuesday, but for today we're just going to talk about rotating using 90-degree angles. An important thing about rotations is that you always rotate counterclockwise. You ask, why do we always rotate counterclockwise? It seems a little bit silly to rotate counterclockwise, but if we look at a coordinate grid, and if we were to label the quadrants, we always label the quadrants in the shape of a C. 1, 2, 3, 4. And I always remembered this because my first name is Chelsea, and it starts with a C, so I make a C on the coordinate grid, or you can make a C for coordinate, whatever you want to make, but it's always a C for coordinate grid, okay? So we always rotate counterclockwise, 1, 2, 3, 4, so I always go this way around the coordinate grid, okay? So there's a couple of things we need to know about the notation. So I'm going to use my red pen. So for the notation, it'd be capital R for rotation. Usually it gives you some point and then some degree. So if I were to look at these different things, the R stands for rotation. The O stands for the point of rotation. The angle stands for the angle of rotation. The pre-image is in the parentheses, and the image is on the other side of the equal sign. So that's all the points of our notation for rotation. Okay, so what is the point of rotation? So the point of rotation is, so make sure I write down exactly what the right definition is. Point of rotation is the point around which the pre-image is rotated. The angle of rotation is how much how far the pre-image is rotated. Positive is counterclockwise. Negative is clockwise. So if I saw a rotation around the origin of negative 90 degrees of point A, that means rotate A 90 degrees clockwise, because it's negative, around the origin. Remember, the origin is the point in the center. Okay. If I saw this, this would mean okay, rotate 270 degrees counterclockwise around the origin. And these things actually mean the same. Since all the way around is 360 degrees, so 360 minus 90 would be 270. So 270 degrees or negative 90 degrees would be the same thing. So we've talked about what the notation looks like. Let's figure out what the formulas are for rotating around the origin. Okay, because there are specific formulas for each of these. Okay. So I'm going to make a nice little grid, a nice little coordinate grid off to the side. I need about this much space to finish up. Okay, I'm going to start with A at 3, 2. So basically, every time you rotate around the origin 90 degrees, you switch the x and the y and make the x negative, or make the x value negative. So if I were to rotate around the origin 90 degrees, x comma y, that would result in negative y comma x. So if I were to rotate around the origin 90 degrees, the point 3, 2, that would result in negative 2, 3. So negative 2, 3. That's where A prime would be. If I were to rotate around the origin 180 degrees, x comma y, I would essentially do two 90-degree rotations. So it'd be negative y comma x, and then I would switch it again and negate the x value, negative x comma negative y. So the rotation around the origin of 180 degrees of 3, 2 would be negative 3, negative 2. A prime prime. Okay. The last rotation we need to know about the origin is a rotation of 270 degrees of x comma y. And basically, I would flip-flop the x and the y again and make the x place negative. So it would be positive y comma x, negative x. So how would this look for the rotation about the origin of 270 degrees of 3, 2? Well, that would be 2, why is this not right? that is right. 2, negative 3. I thought it was right. That would be A prime prime prime, because that's the third time we rotated it. And if you notice, all of these points are always the same distance away from the center of the circle. So if I were to use my compass to measure, and go around the center, they're always the same distance away from the center, which is pretty cool. Okay. The question is, how would you find the center of rotation? We'll talk about that another day. We're already several minutes in. You guys have homework. We'll talk about the center of rotation another day.